In section 8.4, we talk about how to rotate conics. And in this picture here, I have a point. And remember from past that x could be written as r cosine theta and y as r sine theta. Then we have another point that has, in addition to theta, has also alpha. One way of looking or thinking about this point is it's the initial point that's been rotated an additional alpha degrees or alpha angle. If we could rewrite this point here in terms of x and y and alpha, then we would know what to do to our original point with a given angle to get to the new point. Notice that I've taken our new point and I've expanded it by sum and difference formulas for cosine and sine. And then notice that I've replaced the r cosine and the r sine with x and y. So I have an equation that only has x and y and alpha in it that describes the new point. The only issue with our equation right here is it's a little hard to remember. A much easier way to remember this result is to write it in matrix form. Cosine, cosine, minus sine, sine. That's what you should remember. All of the angle of rotation. When we multiply the first row times the first column, we get our first row, first column answer. When we multiply the second row by the first column, we get our answer for y. Notice, though, that x and y, the original x and y, must be parametric equations in order for this to work. And our resulting we call x prime and y prime. So that's the notation we'll use for our new point instead of it also being x and y. So what we have here is a way to rotate something around the origin. It's important that we say the origin because we'll rotate around other things later. This is the formula that you need to remember. Here's an example. If we want to rotate this ellipse right here, 60 degrees clockwise about the origin, so we remember our trig identity, and we set the x equal to cosine, the y equal to sine, and we square root both sides. And we solve for x and for y. Those are our parametric equations. This is negative 60 degrees of rotation, so we do cosine, cosine, minus sine, and sine. First row, first column. Second row, first column. And we have our new equations. Now, certainly you can go to Desmos, and in Desmos, you could graph this equation right here and the original equation, and you would see that it looks to be the same shape, rotated 60 degrees about the origin. What if the original equation is not an ellipse? How do we get it into parametric form? If it's a line, x equals 3, the parametric will be x equals 3 and y equals t. Y can be anything. If it was y equals 3, then y would equal 3, and x would equal t. X could be anything. For a parabola, take whatever the squared letter is and make that be t. And then the other letter can be written in terms of t. Of course, for a point, x and y are just the values. And remember that for a hyperbola, instead of using cosine and sine, we'll use secant and tangent. On our next example, what if we want to rotate something not about the origin? So we have a parabola, and we want to rotate it 30 degrees, but not around the origin, about the parabola's focus point. All right, so first of all, we got to figure out where the focus point is. Remember that A is equal to 4p in standard form for parabola, so p is 2. We can solve for our vertex point, and then we can move 2 from there to find what the actual focus point is. We can also write our parametric equations for the parabola, but in order to rotate around a different point than the origin, what we're going to do is we're going to translate our rotation point, the focus, we're going to translate it to the origin, and then we're going to rotate around the origin. Here's what it looks like. Okay, so here is my setup down here, and let me explain. First of all, it's positive 30 degrees because it's counterclockwise. It's cosine, cosine, minus sine, sine. Why is it now minus 2 when it used to be plus 3? Because I rotated it to the origin, so I had to subtract 5 from the x. Also, I had to add 1 to the y to get this to be to the origin. So I added 1 to the y. Now I'll do my first row times my first column. This will be rotated around the origin. And then to translate it back, I will add the focus point back at the end. So again, subtract from the original parametrics to rotate it to the origin, rotate it around the origin, and then translate it back. Here's our final answer. Remember that when you do the first row times the first column, it's going to be the first times both parts of the first, and the second times both parts of the second. That's why there's 4 parts here. And then plus the 5 at the end. Same for the second part. So again, whatever your point that you're rotating around is, you must translate that to the center to get your new parametric equations, to do the rotation, and then you must add back that same point that you're rotating about. Again, graph it on Desmos, graph the original on Desmos, graph the new equations on Desmos, and see that it looks right.